Good morning, students. In previous class, we had some discussion regarding biodiversity and conservation, and some basic concepts we had a discussion. And in this video, in this class, we are going to discuss a detailed explanation regarding biodiversity and their patterns. So the title name of today's topic is Patterns of Biodiversity. Biodiversity varies with the change of altitude and latitude. The species diversity is maximum in plains. It means at low latitude. Here it is, say some 20 degrees Celsius, and equator, low latitude. So here you can say like 50 degrees Celsius. As we move from lower to higher latitude, so lower to higher latitude means towards like this, 20 degrees, 40 degrees, 60, 70, towards poles. From plains to towards poles, it is from lower latitude to higher latitude or towards poles. At the same time, from lower to higher altitude, means here you can see in this graph, like from equator 0 degrees, 50 degrees, 100, 150 and 200 degrees Celsius towards mountains. This can be represented as lower altitude to higher altitude towards mountains. It means from equator to towards mountains, or here from plains to towards poles. The biological diversity, what may happen, decreases. Here you can see in this graph. So the diversity also depends upon seasonal variability and physical environment like temperature, humidity, rainfall, etc. So here thus the diversity of animals and plants is not uniform throughout the world and shows uneven pattern. There are two specific patterns of biodiversity are available in the world. One is latitudinal pattern. It is also called as a latitudinal gradient. Second one is species area relationship. Before going to learn that topic in detail, I would like to give you a detailed information regarding this particular graph, whereas this is out of the NCERT textbook and important to understand the concept in a well manner. Have you seen the heading here? Distribution of ant species at different altitude and latitude. So this graph is representing regarding distribution of different ant species at different places, latitude and altitude. Okay, now in this graph, one direction towards altitude from equator, one direction from plains, latitude towards poles. So here in this place where there is a low altitude and when there is a low latitude, in this particular area there are more number of species of ants can be seen, but those ants species count can be decreases when we go away from the equator towards mountains at altitude direction. At the same time, those ants count will be decreases when we move away from the plains to higher latitude like 20, 40, 60, 80 degrees. So thus ants counts, what may happen, decreases. Here you can see narrow range, here you can see huge range. It indicates here more number of species of ants are present at equator and plains where there is a low altitude and low latitude. But here if you see 80 degrees, here it means the species of ants count is less when we compare with low latitude to high latitude towards poles. At the same time here also, this area, low altitude area, say 0 degrees to 50 degrees. So more species count, whose count, ants count is present. This count, what may happen, decreases when we go away from the equator towards higher altitude, 50 degrees, 100 degrees, 150 degrees, 200 degrees, and so on towards mountains. So in this concept, what we can understand, in this graph, what we can understand is at low altitude, it means at the place of equator, at low latitude, at the place of plains, at low degrees Celsius, different species of ants are more. They will be decreasing when we go away from the lower altitude to higher altitude, lower latitude to higher latitude. It is lower latitude means plains, lower altitude means equator. So this direction keep on goes 80, 100, 200 and towards poles, and this direction, altitude direction, keep on go towards the 200, 250 towards mountains. So with this graph we can understand very clearly at which place species of ants are more, at which place species of ants are less. Hope you understood this graph, students. And here one important aspect is there which I would like to bring to your notice. The diversity of plants and animals is not uniform throughout the world, as we learned just now, but shows a rather uneven distribution. For any group of plants, there are interesting patterns in diversity. The most well-known being the latitudinal gradient in diversity. In general, species diversity decreases as we move away from the equator towards the poles or towards the mountains, with very few exceptions. So very few exceptions are there for this concept also. Let us have a talk. Tropics, latitudinal range, it means this range. At 23.5 degrees Celsius north, it means, see this one, assumes this is just a globe. This is centrally passing one imaginary line called equator. Either sides of equator, 23.5 degrees Celsius north latitude, 23.5 degrees Celsius south latitude, these red color lines. And after that, towards poles. Here this is North Pole, this is South Pole. So at 0 degrees Celsius, it is at equator, this blue color line. So now we are discussing about tropics latitudinal range. Tropics latitudinal range at 23.5 degrees Celsius north to 20 degrees Celsius 5 degrees Celsius south harbor more species than the temperate or polar areas. So between 23.5 degrees Celsius north latitude, 23.5 degrees Celsius south latitude, between these two ranges, what may happen? There is a more species diversity is present comparatively temperate and polar areas. So this is South Pole, this is North Pole. Okay, now let us see one calculation here. Colombia, here you can see. Colombia located near the equator. Located near the equator has nearly 1400 birds. It means 0 degrees Celsius means here nothing but equator only. So Colombia located near to the equator has 1400 species of birds, while New York at 41 degrees Celsius north has 105 species of birds, and Greenland at 71 degrees Celsius north has 56 species of birds. And whereas coming to India with much of its land area in the tropical latitudes has more than 1200 species of birds. A forest in a tropical region like equator has up to 10 times as many species of vascular plants, and these plants are vascular plants. Vascular plants means here, students, we can go back to first year. Algae, bryophytes, pteridophytes, gymnosperms, angiosperms. So these are the different 5 divisions. First, land vascular plants are called pteridophytes, followed by gymnosperms and angiosperms, higher plants. So here, what the concept is explained to us is here, if a forest in a tropical region like equator has up to 10 times as many species of vascular plants, it means they possess true vascular tissues like xylem and phloem for transportation of water and food materials respectively. As a forest of equal area in a temperate region like Midwest of USA. So this is a very interesting point. So equator has up to 10 times as many species of vascular plants as a forest of equal area in a temperate region like in Midwest region of USA. So at Midwest region of USA, which is located at a temperate region, has equal number of plants which are present at equator. It means like 10 times. So in both opposite places like at equator and temperate region, example Midwest of USA, as equal number of plants, they are 10 times. Those plants are nothing but vascular plants. So here one more interesting point has to be discussed here. Coming to this statistical matter, here in the latitudinal pattern or in the latitudinal gradient, we can know one interesting point. The largely tropical Amazon rainforest in South America. On the land, Amazon forest is the largest forest as per the records. It has greater biodiversity on the earth. Greater biodiversity on the earth means, from all the corners of earth, if you study, this is only the forest, Amazon forest has greater biodiversity with different kinds of species, that too in a large number. Let's see some examples. Great Amazon forest is a home for more than 40,000 species of plants and more than 3,000 species of fishes and more than 1,300 species of birds and more than 427 species of mammals and more than 427 species of amphibians and more than 378 species of reptiles and more than 1,25,000 species of invertebrates. So here invertebrates means organisms which do not possess a true vertebral column, say insects. As we learned in previous videos, in previous classes, out of 100%, 70% are noted animals. If you're making up those 70% animals, in that 70% organisms are recorded as insects. It means out of 10 animals, 7 are recorded as insects. Out of 10 animals, 70 are recorded as insects. So insects count are more here, even in the Great Amazonian rainforest, which is located in South America. Okay, scientists estimated that in these rainforests there might be at least 2 million insect species. How many? 2 million insect species are waiting to be discovered and named. See what a great, amazing thing which we can see in the Amazon forest. Scientists estimated that 2 million, at least 2 million species of insects are waiting to be discovered and named exclusively in the Amazon forest only. And here, let us see one interesting point here, students. My question is to you now. What is so special about what is so special about tropics that might account for their greater biological diversity? Can anybody say answer for this question? I repeat this question once again. What is so special about tropics, like Amazon rainforest, that might account for their greater biological diversity? Yes. Coming to answer, students. Ecologists and evolutionary biologists have proposed various hypotheses. Students, we know very well, hypothesis means which is not having scientific evidence, but it means this is one kind of assumption only, but somewhere some scientific information, scientific knowledge, scientific background can be present for this hypothesis. Okay, now there are 3 explanations or hypotheses for the greater biodiversity in tropics like Amazon forest or Amazonian rainforest. Let us see one by one, students. These 3 are more interesting and important. First hypothesis. Hope you are following. Please listen it very carefully. The tropics have remained relatively undistributed for millions of years. There have been no frequent glaciations as in temperate and hence long evolution time for species diversification. This is first hypothesis. I will explain in detail. Once again, let's see. The tropics have remained relatively undistributed for millions of years. What does it mean, students? The tropics, which are having greater biodiversity, as we learn, here have you seen 0 degree Celsius equator and either sides 23.5 degrees Celsius north latitude, 23.5 degrees Celsius south latitude. When we move away from the equator towards South Pole and North Pole respectively, as we learn, species count, what may happen? Decreases. What may happen? Decreases, obviously. So that's why I have mentioned arrow marks here. So here, in this particular region, between here to here, 23.5 degrees Celsius north latitude to 23.5 degrees Celsius south latitude, between these ranges only, tropics like Amazon rainforest is presented at South America as greater biodiversity. The biodiversity which is present at this range, at this particular place, is not distributed for millions of years together and remained same as it is at the same place. It means the species which are present at this place, at this tropics, they are not migrated to other areas. For millions of years together, they are remained in this particular circle only, in this particular tropics only. Then obviously at this place greater biodiversity is presented, since they are not migrating to other continents or to other areas. At the same time, there have been no frequent glaciations as in temperate, hence no long evolution time for species diversification. What does it mean? Since there is no frequent glaciations at temperate regions, due to high temperature at temperate regions, glaciations takes place. In such a case, what may happen? The species can be extincted, but no frequent glaciations. That is also one of the advantage to have greater biodiversity at Amazon, at tropics. So no long evolution time for species diversification. When there is no long evolution time for species diversification, then obviously at tropics more number of organisms remain as it is. How come it is? Evolution. Let's see about evolution, a small recap. Human beings evolved by a process called as evolution. We know this one. If evolution does not take place in human beings, what may be the condition? We might have remained as early man only. Isn't it so or not? So here, students, no long evolution time for species diversification. When there is no long time evolution for species diversification, obviously those species remain at tropics without distributing to other areas. So this is one hypothesis, first hypothesis. According to ecologists, according to other scientists, for the region of presence of more biodiversity richness at tropics comparatively poles. Now, hope you understood this one. Students, let us go to second hypothesis. The tropic environments are more constant or less seasonal. This is very interesting. Now let's talk about it. The tropic environments are more constant. So here, tropics, just now we had a discussion. So between 23.5 degrees Celsius north to 23.5 degrees Celsius south, tropics which are present at that place, the environments are more constant. So they're constantly present without changing frequently. When they're not changing frequently, then obviously seasons are less. So this can be one of the advantages to have more species diversity, as we learn these many statistics, these many different kinds of organisms at Amazonian rainforest, which is located at South America, situated at tropics. Now, let's talk about third hypothesis, a third explanation to have greater biodiversity at tropics. Yes, tropics have more solar energy, contributing to higher productivity, hence greater diversity is present. Obviously, students, equator near to the sun, then obviously the temperature or the solar energy is high compared with the poles, South Pole and North Pole. Here the South Pole and North Pole both are receiving slightly and slantly sun rays from sun since the seasons are long. This is because might be learned in school days at South Pole and North Pole 6 months daytime, 6 months nighttime. Why? Because they are receiving low amount of sun rays, and far, one more reason, they are very far to sun. Then obviously here the temperature is very cool. When the temperature is very cool, like minus degrees, like minus 50s, 80s, 100s, how can more number of organisms can grow? How can we see species diversity, rich biodiversity at South Pole and North Pole? Obviously no, nil. At the same time, very few organisms are surviving at this particular places like polar bears, penguins, etc. But coming to third explanation hypothesis, here the tropics have more solar energy since they are very close to sun. Suppose assumes this is sun, they're close to sun, obviously they receives more amount of sunlight, solar energy, and contributing a higher productivity. When they are receiving high amount of solar energy, since these are having 40,000, more than 40,000 different species of plants, and obviously productivity is more. Productivity is by photosynthesis process. Then they produces more amount of starch. Since obviously on these plants, since plants are nothing but primary producers, on the plants which are all other third levels of organisms are depend, like primary consumers, secondary consumers and tertiary consumers respectively, from lower to higher. All the three levels of organisms are depend upon. Then obviously those all three levels of organisms are present at tropics only, since there is a more productivity by the producers comparatively poles. So obviously biodiversity richness is more at tropics. So these are the three hypotheses by ecologists and other environmental scientists. Now one more point I would like to bring to your notice. These are all different hypotheses, explanations to know how species diversity is present at tropics. So this is latitudinal pattern or latitudinal gradients. Hope you understood the first pattern of biodiversity. So before going to discuss about second pattern, it is species area relationship, just for 2 minutes let's have a recap based on today's class. Students, the most important point what we have to understand is distribution of organisms or species is not uniform throughout the earth. This point must be clear to everybody. So this concept let's see in a graphical representation. In this graph, if you see one direction altitude, one direction latitude, here low degrees equator and plains. Low altitudes, it means equator. Low latitudes, it means plains, consisting more number of different species of ants at altitude and latitude respectively than when we go away from these places. Away from these places means from 0 degrees Celsius towards the higher altitude, towards the higher latitude. It means from plains towards poles, from equator towards mountains, species richness what will happen? Decreases. So this is only a best explanation to understand how species richness is decreasing when we go away from the equator to other areas, poles and mountains. Okay, now this distribution is arranged in different patterns. Those patterns are popularized in two methods. The first method is latitudinal pattern. The second one is species area relationship. So now in the first pattern, latitudinal pattern, we can understand one important point. Yeah, near to the equator, the place is Colombia, has nearly 1400 species of birds, whereas New York at 41 degrees Celsius north has 105 species of birds, whereas Greenland at 71 degrees Celsius north has 56 species of birds, whereas India has 1200 species of birds. And one more interesting point, equator has up to 10 times vascular plants when we match with a temperate place like the Midwest of USA. So here one interesting point I would like to bring to your notice. Here, coming to this diagram, latitudinal pattern, when we move away from the 0 degrees Celsius equator towards poles, the species richness decreases. So there is a more species richness is present at tropics region comparatively poles and temperate regions between 23.5 degrees Celsius north to 23.5 degrees Celsius south. So example, Amazonian forest, which is located in South America, has more than 40,000 species of plants, more than 3,000 species of fishes, 1300 species of birds, 427 species of mammals and amphibians respectively, and 378 species of reptiles, and 125,000 species of invertebrates, example insects, and amazingly nearly 2 million species of insects are waiting to be discovered and naming in the Amazon forest only. So students, hope you understood today's class. In the next video, in the next class, we will discuss more information regarding species area relationship. So I request everybody to take down this graph and this diagram also, which are more important for the PU board pattern, and this can be asked as a 5-mark question. So at that time, based on these diagrams only, you can write the explanation, and this question can be asked generally with the combination of species area relationship for 5 marks. This is one of the standard important question for PU board examinations. And coming to neat part, statistics, different species of organisms which are present in the Amazon rainforest. These figures can be jumbled or can be given wrong for one multiple choice question. This is one important standard area. At the same time, 2 million species are waiting at the Amazon forest only. Especially 2 million species of insects are waiting at the Amazon forest for discovery and naming. That point also is important for competitive part. And this statistical part, this part is also most important. At equator, how many which place is located, how many birds are presented. At New York, how many birds. At Greenland, how many birds. And in India, how many. And this can be also asked by jumbling or by twisting, or by giving a wrong one MCQ multiple choice question. So thank you for today's class. Thank you for your time, students. We will learn next pattern species area relationship in the next video, in the next class. Hope you understood today's class. We will continue in the next class. Thank you, everybody.